Hello, in this video we're going to discuss particle colliders part 2, types of particle colliders. So in this example we've got the ring type particle collider, and you just notice that the start point is right next to the collision point, and in this example it would be in a clockwise direction that the particles travel. So remember, we have two particle accelerators. One should be for the particle and the second is for the carbon, for carbon bonding. And we have our collision point right next to our start point. So you don't have far to go with this type of collider in order to inspect the results. So that's the ring type particle collider. Here's the second type of particle collider, the straight line collider. So at one point, at one end is the firing point, at the other end is the collision point. The important thing about this collider is the run needs to be long enough in order for the particle to go beyond the speed of light. That's the important thing. This particular kind of particle collider is good for the manufacture of isotopes. So you've got two tubes side by side. One is carbon, the other is the particle. And if you wanted to increase production and halve the amount of time it takes to create more particles, then you double the number of barrels. So you'd go from one particle and one carbon to two particle and two carbon, would give you twice as many particles per each run. And if you were to double that again, go to 4 and then 8 and then 16 and then 32 and 64 and 128 and 256 and 512 and 1024 and 2048, then you get an idea of how many barrels you can use in order to create more isotope faster. So for manufacture, this is a good design, and you can add more next to it and create more isotope faster. So remember, it's particle by particle of isotope that's knitted together. Okay, so the third type of particle collider is a ring type particle collider in space. And the fourth type is a straight line particle collider in space. Now, the fifth kind of particle collider is a straight line interdimensional collider. So this technology is heaven's tech. And what you have is a firing point at one end, like the straight line. At the other end, you have a interdimensional collision point wormhole with multiple mediums for the collision. So this kind of collider is in a dimension bigger than this universe. The length of the collider is longer than the length of this universe's dimension, and the collision point is interdimensional. so the particles, carbon and the particle, go through a wormhole whilst still travelling at tremendous speeds and collide with the bonding, with the collision particle in another dimension with different mediums. So you've got a vacuum, plus you've got air and water, and all sorts of compounds and elements that you can use in your interdimensional collision point. So this greatly increased heavens technology recently. So the idea came about a few years ago. We can see signs of the technology here on Earth. So prior to this, the cigar-shaped spaceship Melissa 347 was created using the earlier technology, which was not like this. So the benefits for Heaven's society with particle colliders includes things like oils and lubricants and materials that last for a long time, literally forever, some of them. For the interdimensional collision point, the particle does not slow down. So it covers the distance in 3.4 seconds. There's more than one collider of this kind in heaven. They're quite massive. Here on Earth, the aerospacecraft Griffin was created as a result of what technology was discovered with this kind of collider. So that's where technology can go with particle colliders. With particle colliders in heaven, in the first history onwards, it reached a point where it was stagnant and we could not go any further. And then this idea of a interdimensional collider made it possible to go beyond where heaven had reached before and come up with new isotopes and compounds. So the benefits for humankind with a particle collider are enormous, but it can be frustrating. It can take a long time just to make a single kilo of isotope for you to experiment on. And the isotopes, it takes a long time to find a use for them. But that's science, and that's what happens when you come up with new isotopes. Sometimes you can come up with new stuff straight away. Other times it can take an extremely long time to find a use for something, while others sit on the bench and you still can't figure out what to do with them. It's impossible to create any form of black hole or destructive force from using a particle collider. So you don't need to worry about black holes simply appearing. The element required for a wormhole is wormhole element, and we do not use wormhole element at all in any way, shape or form for particle colliders, because we simply don't know what it's going to do. And that's why that element is not used at all for this kind of thing. I'm the Archangel Daniel, and I'm from heaven.